Okay, so I'm going to do an example of finding the derivative of this function where we don't have the rules for the derivative yet. So what we are doing is finding the derivative using the definition of the derivative as a limit. So I'm going to find the derivative of this function um, and then use that to find what is the value of that derivative at these 3 points. This is a problem from the homework. Okay, so the definition of the derivative that I think we need to be very familiar with is that the derivative of a function f is a new function called f prime, which is the result of getting this limit. It's the limit when h approaches 0 of the difference quotient. When you evaluate f of x plus h, get away of f of x divided by h. I'll explain in probably in another video graphically what this is, but this is the slope, right, of between 2 points, nearby points at x and x plus h, and you're taking the limit when those 2 points very, very close. So at the limit process, after the end of the limit process, this is the slope of the tangent line. Okay, so algebraically, what do you do? So algebraically, what I'm doing is I need to find this limit when you have to evaluate the function at x plus h. So my function is 3 root of x, so when I evaluate x plus h, it becomes 3 times the root of x plus h, right? That's this part here. And now I'm going to do this part here. Let me see if it doesn't make sense. Now I'm going to do minus f of x. So I'm going to do minus 3 root of x. And this is this part here. Now, where do I got this color from? This one. Right? So this is this, and this is that. Hope you see what's going on. And I still have to divide by h. Okay. Now, what I mean by doing this algebraically means that we need to find a way to simplify this in a way where the problem that we encounter right now is that if we plug in h equals 0, the top is a 0 and the bottom is a 0. And that's not defined. But there's a, whenever we ask you guys to do a limit, what this means is that there should be an algebraic trick that makes to simplify this so we can cancel a factor of h from the numerator and denominator. And after we cancel that factor, then we can use h equals 0 and find a numerical value, or in this case, an x value. So what is the trick in this case? The trick when you have a square root in the sum or difference of square roots is to do this. We have to remember that if you have a plus b times a minus b, you get the difference of squares, right? So why do I mean I'm going to do that? Because this is going to be my a, this is going to be my b. So I'm going to see it like this. So if I multiply by a plus b, on this side, they're going to screw up. They're going to cancel, and I'm going to have only these terms squared, which really means get rid of the square roots. So first thing I'm going to do before I do that in this case is just factor that 3, because that will make things a little bit easier. So I have a 3 here, and I have this. Oh, I forgot my x, sorry. X plus h minus root of x over h, okay? And what I'm going to do, so factor the 3, what I'm going to do is multiply by this a plus b, which what I mean in this case is going to be x plus h plus root of x over x plus h plus root of x. Why am I allowed to do this? Because this thing I'm multiplying here is really just a number 1, right? So nothing is affecting my answer from before. But by doing this trick, what I gain is that this becomes this. In the top, this is like a minus b, a plus b. So my result is a squared, so it's just a quantity x plus h without the square root, because it's squared now, right? Minus the quantity b, which is just x, because it's squared now, right? Now, in the denominator, it doesn't look any nicer. I'm not even going to bother in multiplying this, and you'll see why in a minute. but it looks like this, right? So the top, using this property over here of binomials of the difference of squares, again, like this is my A, B, and B. Here it's with a minus, here it's a plus, so it becomes A minus B squared. So what happens is that in this numerator, the x's cancel, and I just have an h, right? These x's cancel. So I have an h, and have multiplying this. And that's why I didn't even bother multiplying these out, because I want that h in the bottom factored, because now I'm going to simplify it, right? And this also cancels. So at the end, I get to this as a result. I get a 3 in the top, and I get root of x plus h plus root of x. So this is the goal always when these limits process. I want to have an h in the top and h in the bottom that once it's a factor, common factor in top and bottom, I can cancel it. And then I have no problem, if you notice in this last expression, there is no problem with plugging in h equals 0, right? At this point, if you put h equals 0, you get 3 over root of x plus 0, so the root of x plus root of x. So it's 3 over 2 times the root of x, right? So that's our final answer. So we're going to be, we have a nicer way to find this derivative in the next section. And maybe some of you are seeing that already, but this is the way you would do it with the definition of the derivative. The definition of derivative is this. Okay, this is what the definition of the derivative is. If you ask you to find a derivative using a definition, this is what it means, to write that limit and do it algebraically to find what the value is. Okay, once I find this, it's pretty simple, right? I can find the answer. The problem still said, find the derivative at 4. So at 4, this becomes, I'm over here in this corner, right here in the corner. F at the prime at 4 would be 3 over 2 root of 4, which is a 2, so it's 3/4. At 0, it's not defined, because I cannot plug in a 0 in the denominator. And at -2, it's not defined, because this is not, I cannot plug in a -2 inside the square root. Okay? Okay, so this is a problem. Hope I will do more videos, and I hope keep asking questions and I make more, and I hope this simplifies, help you do more problems like this. This is 11.4.